2009, number 5. Let's see what we have here. We've got let f be a function that is twice differentiable for all real numbers. It just means we can talk about all its derivatives and not worry about anything. The table above gives values of f for selected points on the interval from 2 to 13. They want us to estimate f prime of 4. Well, let's see. To estimate the slope at 4, I just use the points on either side of 4. So f prime of 4 is approximately equal to the slope of those points on either side. So that'd be y minus y over x minus x. That's negative 6 over 2, or negative 3. And there's the work that leads to my answer. Well, that was easy. Evaluate this integral. Well, let's see. Let's just write that down and start doing some calculus and see what happens. 3 minus 5 f prime x dx. Well, let's see. The antiderivative of 3 is 3x minus 5 times the antiderivative of f prime is just f from 2 to 13. Now that's equal to, plug 13 in here, that gives me 3 times 13 minus 5 times f of 13 minus what I get when I plug in 2, 3 times 2 minus 5 times f of 2. Right? And then I think I can get these values out of the table up there. So that's equal to 3 times 13 is 39 minus f of 13 is 6. So 5 times 6 is 30 minus 3 times 2 is 6 minus 5 times f of 2 is 1. That's just 5. So that looks like 9 minus 1, 8. Okay. Part C. Use a left Riemann sum with intervals indicated by the data in the table to approximate the area. Alright, so this area is approximately equal to, so this is 1, 2, 3, 4 rectangles. The first rectangle is 1 wide and this high. I'm always using the left endpoint, right? They asked me to do a left Riemann sum. So it's 1 wide and 1 high. The next one is 2 wide and 4 high. The next one is 3 wide and negative 2 high. And the last one is 5 wide and 3 high. So that's 1 plus 8 minus 6 plus 15. So that's 9, 3, it's 18, I think. Can check my work there. Okay. And then, whoops, sorry, you couldn't see any of that, could you? There it is. There's my first rectangle, 1 wide, 1 high, 2 wide, 4 high, 3 wide, negative 2 high, 5 wide, 3 high. And I got 18 there. All right, let me try to do this part where you can see it. Part D, suppose that f prime of 5 equals 3, and the second derivative is less than 0, in other words, it's concave down, for all x in the closed interval between 5 and 8. Use the tangent line to the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. And then use the secant line for the graph to show that f of 7 is greater than or equal to 4/3. Alright, let's just find the equations for those lines and then we'll worry about the other stuff. So use the tangent line to the graph of f at x equals 5. Well, at x equals 5, we have the point 5 comma negative 2. And they told me the slope, that the slope is 3. Right? So that would have to be the line y minus negative 2 is equal to 3 times x minus 5. And writing that, that'd be 3x minus 15 minus 2, 3x minus 17. Okay? Now what do they want me to do with that line? They want me to use the tangent line to show that f of 7 is less than or equal to 4. Alright, so y of 7 is equal to, if I plug 7 in here, I get 4. But this is an overestimate because the second derivative is less than 0. And if you want to remember what that looks like a sort of visual for that, if the function's concave down, then its tangent line is always going to overestimate because the function's going to be bending down away from the tangent line. And I think the other part's going to go in a similar manner to this. Let's find our secant line. Secant line actually connects 2 points. So it's between the point 5, negative 2, and 8, 3. That slope, y minus y over x minus x. And remember, this, you haven't done this since a long time, but you can use either one of those points to find the equation. So that gives me y is equal to, y minus, I'll use the same point, negative 2 is equal to m times x minus 5. So that's, let's see, y equals 5/3 x. That would be minus 25/3 minus another 6/3. And plugging, what are we supposed to plug in? 7? So y of 7 is equal to probably 4/3, right? So that would be, yeah, that's 4/3. Now, here's your picture. Here's your 2 points. If the function is concave down, that means the secant line, just like our other picture, secant line underestimates when the second derivative is negative. Oh, that's kind of a cool part there, I thought. Secant lines, tangent lines, good stuff.